for those who have a Gaia account, this is going to be kind of like your free 101 introduction class. So the whole idea, okay, free stands for the FMS Runtime Environment, and that's something that's been developed at GFDL to run the climate model first and foremost, but that's also used to run like ice ocean configurations. And the whole idea is that it's supposed to make it simpler for you to run like those big climate simulations on the GFDL infrastructure. So it's very GFDL specific. It works on Gaia, it works on a couple other platforms, but it's not something designed to be ported to your like at HPC outside of like, NOAA infrastructure. So, okay. So what we're gonna do first, I'd like you to connect onto Gaia and follow those simple instructions. So we're gonna compile the model first because this can take a little bit of time. So I suggest we start with that. Then I'm gonna run you through some slides. And then at the end, we're gonna do some like hands-on experiment. So it's actually pretty simple. You SSH into Gaia. Hopefully, if you've done that before, you put in your magic pin and RSA. You do your module load free, and in that case, the current version is Bronx 19. And then you're gonna clone that repo that I worked very hard on it last week for you to get like some very simple curated XML that we're gonna start playing with and that we're gonna modify and hopefully make some pretty cool simulations with it. So you clone it, and then everything should be in the README. So if you do that more README and you grep FreeMake, that should give you like those two commands. So please don't type it, just do the more README and grep FreeMake. That should come up directly. And then you just have to copy paste that into your Gaia. I mean, you need to clone this onto Gaia. I hope that was clear. So you clone this onto Gaia, you grep the FreeMake commands into the README, and you paste that inside your XML repo. That should clone a bunch of different things and then give you like to submit the script, copy paste as batch something that's going to be a long name with a script. So please run that and do the same. So we're going to do one for the ocean only and one for the ice ocean. So that's why there's like two FreeMake script to do. I think the instruction clear. I hope I didn't go too fast on that. You guys all okay on that one? Or if you're not okay, just raise your hand if you didn't understand the instructions. No, okay. Looks like everybody got it, so that's good. Again, like cloning and compile, and once you submit the script, it's gonna be like compiling the thing. It might take a little while, so that's why I'd like us to get started on that right now, and then we'll start like playing with the XMLs. Oh. All right, awesome, thank you. All right. So, all right, let me move on. All right, so why are we going through, all of this? So one thing that a lot of people get confused with is what's the overall infrastructure of like the HPC with GFDL. So one thing that you need to know is there are two sites. When you're logging onto Gaia, you're logging onto a machine that lives in Tennessee, and you're logging from probably from GFDL, from your home office. So that HPC that lives in Oak Ridge has like different partitions. It has like, so it has the partitions here are like where you're gonna submit the job. So it's basically gonna be block of cores. So they are labeled like C3, C4, C5. Don't ask me why, because I have no idea, but that's how it is. And everything is under like a Lustre file system, and it's Lustre F2, which are going to be basically the root of everywhere you go on Gaia, pretty much. So that's on the Gaia side. On the GFDL side, you're probably used to running on PPAN or analysis. That's typically the name that go for like that HPC. And that HPC is much smaller in size. It's not dedicated to like running climate models. It's mostly dedicated to running all the post-processing and doing all sorts of analysis. And you can just tell by the numbers that there's like order of magnitudes in terms of how many cores or processors between the two machines. So again, we have that huge machine in Tennessee that we're running things on, and we're gonna post-process and analyze the data at GFDL. So what's happening between the two is that we have like a very high-speed data transfer that happens, and everything that needs to happen between the two sites is orchestrated by FRE. So what you used to do, you're behind your computer, you used to SSH either onto GFDL machines or onto Gaia. And both of those sites you can access through SSH, but there's two sites, so Gaia and GFDL are gonna be communicated through some very high-speed data transfer protocols. And typically, the tool behind those different like transfer protocols is called GCP. It's like a copy over like a grid FTP protocol that's designed to like really make very quick transfer. So you have a quick protocol over like fiber type of like of hard connections. So so everything designed to go fast, but kind of like everything also a little bit under the hood so that the user don't have to worry too much about it. So your typical workflow. So basically what's going on when you're running a climate model. So first step is you're gonna be compiling the climate model. So you're gonna have that FreeMake step. So FreeMake is gonna be the tool that you're gonna be using to compile the whole climate model. And the model can be a little complex. So we compile like just MOM6 and FMS this morning, and you saw that it could be like a little bit tedious. Now imagine you have to add the land model, the atmospheric model, you have to add like ocean BGC, for example. So it can grow up in complexity pretty widely. And so that's what Free and FreeMake are supposed to make a little bit easier on you. So it's kind of like orchestrating how you're gonna be compiling your climate model. So once you get the executable, you obviously need to run it. And that's where that free run command is supposed to help you also building like the whole script to be able to run the climate model, building a script that's gonna run like the climate model for a year and then resubmit itself until you've done like the 100, 200, 300 years or how many years you want of simulation. And once every year, when every model year, once your output is written, is gonna be like basically processing the data. So the first step is like typically when you have like a big climate model, you cannot write the entire domain into one file because it becomes too big and it becomes like an IO problem. So you have to basically break it down in, say, for example, 16 subdomains. Those are not like the subdomains that your model is using, like each core is run by maybe like 20 by 20, say, like points, but you're gonna put like subdomains of, say, 200 by 200. But once you get all those different files, you want something that you're gonna be able to look at. So there's gonna be a step that's gonna be recombining all those different outputs and packing them into a tar file so that it can be transferred to GFDL in a way that's gonna be efficient. So again, I don't want to go too much into the detail of like why it's done that way, because I think it's been done the proper way for like, you know, efficiency reason. I didn't dive that deep, you know, in the weeds to know the exact details, but basically everything gets recombined, packed into tar files. So outputs on one side, restart, and log files, so ASCII files, and all of that then gets shipped to GFDL with that GCP protocol to that, so that everything gets moved pretty fast between the two sites. Then when it gets to GFDL, there's another round of stuff that happens. So basically, you get your output tar files, and we have like several processes that happen. The first one is called the refine diag, and that one is basically some derived quantities that are generated out of the raw output, and it's mostly related to ocean and atmosphere. So I listed there like a couple of like diagnostic that are processed typically in those refined diags. And so this is going to create like yet another set of like tar files with those new diagnostic. And once you get that step done, it's going to run like a post-processing, which basically means that they're going to unpack files from the tar files, and they're going to start like building time series or time average of like a given length. So that's parameterizable. You can say like, oh, I want my file to be like in time series of 20 years or 5 years, or I want average every 10 years. So that's something that you're going to be defining into your input XML. And then the post-processing is going to create actually a copy of all your output file, but like in a format that you're going to be able to just access, read through Python, or look at with NCView and whatnot. How am I doing on time? Okay. So there's a naming convention to it, and the naming convention is like makes very long files, but it has kind of like a reason to it. I mean, there's like an FMS tag that basically gives you an information on what's the version of the model that you use. So the FMS plus whichever like ocean model, or you'd have to pick a tag. It's give you like some sort of like version of your model, an experiment name that could be CM4, ESM4 with some sort of like conditions, PI control, historical, or something. A platform and a run type. So the platform is where did the model run? Did it run on Gaia? In that case, that's going to be like a NCRC 3 or 4. What was the run type? Was that like a debug run? Was that like a production run? And then after that, all sorts of like subdirectories that can happen later. So now what's where? So bunch of different repository. Again, on Gaia, there's like 3 main places where you're gonna find your data. So /dev is where the model is going to get built, and that's where your executable is going to be saved. That's where the scripts to compile and run the model are going to be saved, and that space doesn't get scratched or like wiped too often. So it's more or less a safe place for your executable to live. On the contrary, the /scratch is the thing that gets wiped out like pretty often. And so in there, you're gonna have like a work directory, and that's where like the individual jobs are gonna run. So if you have like a model that's running and you wanna see, you wanna take a look at the log file as it's running, that's where you would want to go. And there's also another place that's gonna be under Scratch, but in that case, under the FMS tag, that's where it's going to be staging like all your output files, like the history, restart. And that's good to know that this exists because, say, for example, your transfer didn't work properly between Gaia and GFDL. This is where you would find like your output files after the model has run. And if you need, you may have the case that you need to transfer it manually or like copy stuff manually, and that's where you want to look at. On the other hand, on the GFDL side, sorry, that's a lot. So on the GFDL side, you're gonna get a copy of the XML that you have on Gaia. It's gonna be copying on your home directory. And then it's gonna be putting like a lot of different things in different places. It's gonna be putting some logs and scripts in your home directory. Is going to be putting some analysis figures and things like that in your NB home. So you have to be careful because this tends to fill up really quickly, and so it's not unusual to have like an out of space, you know, on your quota just because your free repositories went a little bit out of control. So you may want to purge that once in a while. You know, make a tar file, put it on archive where it's safe. And finally, the most important is going to be on archive. And on archive, that's where you're going to get like all your history files. You're going to get the restart, the logs, and the PP files. The PP subdirectory is where it's actually going to give you all the netcdf files that basically 99% of us are using and are looking at. We are typically not looking at what's in the tar files. We're just looking at what's in the post-processing directory. So I'm gonna go maybe a little bit faster now, because that's stuff that we're gonna try to do together with the sample XML. But basically, the idea is that you need to get some XML from somewhere. And in the XML is going to contain compilation instruction, runtime parameter overrides, input files, processor count. Basically, everything you need to run the model is going to be packed into the XML, which kind of like you have everything. It's kind of like a blessing and a curse in a way, because that makes it also pretty hard to read at times. So basically everything is in there, and it's both a good and a bad thing in a way. So the first step, basically you need to, and you don't need to do that thing right now because we're gonna work off like a different set of XML, but basically you need to find some XML somewhere, and that's usually something you're gonna get from like a colleague, from your advisor or something. You have to start somewhere. And then starting from that XML, you're gonna start like modifying it and generate your own experiment. So again, FreeMake, that's what's compile your model. I'm not going through all the things there because we're gonna be doing it together. It's on the slides. The slides are gonna be available if you want to use that as kind of like a reference tutorial or something. So FreeMake to compile, FreeRun to generate. So FreeMake to generate the script to compile. It's always, so FreeMake doesn't do it. It generates a script to do it. And then it's up to you to submit the script. Same thing goes for free run. Free run generate the script, and you have to submit the script. So, however, here I want to mention just like a few things of interest. You have like options to free run. Say for example, you made like a 1 year run and you made a mistake. If you try to rerun free run, it's not gonna have it. You need to specify like overwrite if you want to scratch everything you've done before and start brand new, or if you had run say a 10-year experiment and you want to make a 20-year experiment, you want to extend it, then that's why you would run the extend. You would add the extend command so that you don't scratch the 10 years you've done before and you don't have to start over. So there's like, okay, different things. We're gonna go through that actually in the tutorial. So we can change the runtime parameters. We can change our input files. We can I'm gonna make just a quick note on inheritance. So in your XML, you're gonna have multiple experiments. So your first experiment is gonna be your compiling experiment. At minimum, any experiment that you run needs to inherit from the compile, because the compile is where your code that give you the information on what your code is. So say your experiment, your CM4 experiment is gonna inherit from the CM4 compile. You can make other experiment that's gonna inherit from, say, your CM4 experiment if you're making like a sensitivity, or if you're running like 6 cycles of like repeated forcing, that's things that make sense to use it as an inheritance. You have to be mindful though that it can become pretty busy, and if you put like experiment after experiment after experiment, you can start getting lost in what is exactly inheriting from what, and that's usually when mistake happens. So I would say keep the inheritance to a level that you can actually manage it, because there's a lot of room for like mistakes in there. We can add diagnostic, we can change the post-processing, can change the code, but that that we're gonna be doing together. Solving the common problems again, that's something that I put in the slides. I want you guys to look at it like later, but I think now is actually a good time to get started with like running the little like examples that we have from that repo. So hopefully by now you have at least one model that compiled. And you can take a look if you do your SQ on Gaia, you can see if your model actually compiled or not. So I'm gonna have like a different like exercises that we're gonna go through. If you look up my my GitHub repo, the different exercises are also like written in the README, so that can be something also useful for you guys if you wanna follow along. Yeah. It's giving you like to compile your script, copy paste this, and there's like a slip one S batch something, and that's what you're supposed to copy paste and execute. Yeah. All right, so I think this, I'm gonna have to stop sharing that so I can switch to the other. Okay, so you guys are seeing that. Okay, good. Yep. Is that big enough? Yeah, okay. All right, so I hope I compiled my my executable too. All right, let me see if I go to. I'm gonna go to my /dev. If I go to my /dev, that's typically what I see. I've got like an FMS 2021-03. That's my version of FMS. Oh, okay. How do I change that? Better? Hold on. Okay. I was trying to share my screen. I think I got kicked out of Zoom. Oops. Yeah, but no, you're not seeing anything. You have like something there, but it's not me anymore. Okay, I need to restart Zoom, I think. No, but the Zoom app crashed on my computer, so of course you had to. It was working so well. I know. It had to be me. That's right. Meeting. Okay, it's being recorded. Okay. Yeah, I'm trying to resize. I don't know. Ah, okay, getting better. Problem with this guy here. This one here. This is they can't get rid of this. Why is that going away? Because when I'm looking at it, you don't have this bar here. Why is that there? The options. Just do that again. Try full screen. How do you go into full screen? This looks okay. Try that. Okay, try that. Okay, so that looks about right. So normally, if all goes well, you should have stuff in there that looks like MOM6 compile and MOM662 compile, hopefully. So that's gonna be in Luster, F2 dev, obviously your username, and it should be the same FMS tag. So just a quick show of and who got at least MOM6 compile in there. You submitted it when, like 2 minutes ago? Okay, that's why I had that in the beginning, because it's probably gonna take like 20 minutes or so. Okay, so I've got only one who's got 2. Okay. So I get 4 out of 6. Okay. All right. So let's get started on basically trying to edit the XML, and hopefully by then some of the compile is gonna be finished. Okay, so I'm gonna go back to where I cloned my XML. And so the first thing we're gonna look at, sure, that's gonna buy me a bit of time. I'm gonna look at my compile ocean only. So compile ocean only is gonna be the XML where I run the compilation for FMS and MOM6. So in that case, it should be a pretty short XML where I get my experiment name here, that's MOM6 compile. And the first step is to compile FMS. So there's a lot of little flags there that is telling FRE where to get the model, what version to get, and some compiling instruction for the preprocessor in that case on how to compile properly. And then, so that's going to be the first thing that that FRE is going to do. And then the second is going to be MOM6. MOM6 requires FMS, so it's going to start with FMS. Once FMS is built, it's going to be building MOM6. And if you remember what you type from the makemf commands, there was like a lot of path that you had to add on that line. I don't know if you paid attention or not, but there's like basically different subdirectories that you're going to be using. For example, like infrastructure FMS1, I'm going to use a memory dynamic symmetric, solo driver, and so on and so on. So all of the path that you use to control basically your internal configuration of MOM6, you're going to be putting in there. And then again, that's going to be just like pulling the MOM6 repo out of GitHub. In that case, I want to be able to check out like a particular hash of my choosing. So that's what that little block is doing. It's just like doing a git checkout of the hash that I want and passing the proper compiling instruction. And that's it. So basically doing like an ocean only XML to compile an ocean only is actually pretty straightforward once you've been initiated to how FRE is working. So I have it running. Well, I have it compiled from last week because I had time to do it. So now what I can do is say, okay, well, you guys were gonna do like some, Philips on your laptops and everything. And I was like, hey, I want to do that too. That looks fun. So I asked Alistair for his like mom of a ride. And I was just like, okay, I'm gonna do the same thing, but I'm gonna do it on Gaia. So I'm gonna write my XML. And in that case, in the XML, I'm gonna provide basically pretty much the same instruction that Alistair showed you with like the input NML, the MOM input and everything. So first block there is more like related to, okay, what are like the different version that I want to use. Okay, so I'm gonna have like, I'm gonna have that FMS 2021-03. That's a particular release of FMS that I know my current MOM6 hash is working with. So I'm gonna use that. bunch of different um, bunch of different uh, flags, and then my compile is actually just like a link to that previous XML that I showed you. So those include allows you to kind of like split into like different files, so you don't end up with like a file that's like 100,000 or million like lines long. So again, use it carefully, knowing what you're doing with it. And then I say, okay, I'm going to write my own ocean-only experiment. I'm going to do that Phillips 2 layer. So Alistair showed you that you had that input.nml that contain different blocks of name list. For example, mom input NML, diag manager NML, FMS NML. Those I just like copied from input.nml, and I added that in a name list block. And that's basically the same thing that you have in input.nml, but just in like a slightly different syntax. Ocean solo NML, that's how you control where your model starts, the calendar and everything. And that part is important. That's also controlling how long your model is going to run. So in that case, I want to run it for like 2 months. I can add some input files. So in that case, I didn't want to, well, we had the mom input. So I know that mom input lives in MOM6 example. So I was like, okay, I can just like put the path to that file, and I'm gonna label it as being like an input to the model. And I'm gonna tell basically the script to copy it into that uppercase input directory. So basically, that's just like a very big CP, if you wish. It's not doing a whole lot, but it's just like passing that to the script to copy it the way you need it to be copied. I'm going to do the same also for the diag table. The diag table here is a little bit finicky. This one needs to be treated a little differently. You need to pass it that labeled diag table, because the way it's going to be processed is going to be done in a way that's a little bit different than just a CP. It's probably going to be more like a cat for people who know it. It's just going to be concatenated the different things into that diag table file. And again, it's going to be set in the input. And for the mom overrides, I just did took the same thing that that Alistair had in mom override. Just has to be put in like a CSH block that has that that cat and EOF, which basically said, okay, everything that's between that line and mom override EOF is going to be written into that work. So the work directory input mom override. Like Luster, Dev, MOM6 example, no, that I had it like checked out myself on Gaia. That's not done automatically. That's something that I did myself, because I wanted just to grab the file from wherever. If you were to run, say if you're going to run like a climate model or like an ice ocean model, there's going to be like a bunch of files that you're going to need from a bunch of places. And so you had to add those somewhere, but that's not automatic. You have to design the thing so that it goes and get like whatever input files from somewhere. So that's up to you to design. And then, so that's pretty much it for the input. The last thing that I need to say is, okay, what is going to be my computer layout? How much resources am I going to dedicate to that? And so in that case, I'm just going to tell it that I want to use that type of resource. So there's like resource param one node that we're gonna go check right now. That one I added on the top of the thing. And that's something like very generic. That's like, okay, one job is gonna be like a 1 hour wall clock. I expect all my job to fit into 1 hour. So that's gonna be my sec runtime. The idea there is that you can run multiple segments per job. And that's useful, say, for example, you know your climate model is taking 4 hours to run, but your max wall time is 16 hours. Well, you say that, okay, well, I can fit 4 years into one job, so I don't have to resubmit every 4 hours. I can just like ask for like 16 hours, and I'm gonna run 4 years. So that's all it's doing. And then in there, I'm just gonna pass, okay, what is my, the number of tasks or ranks that I'm gonna run. In that case, I'm gonna run 36 of them. I'm gonna make it like a 6x6. And my IO layout is just gonna be writing in one processor, one file, sorry, one big file. It's small enough that I can do that. I don't have any LAN processor elimination. If I had, I would add like the name of the mass table. That's a text file that basically lists all the processors that can be eliminated because it's only LAN points. And threads is only if you're using OpenMP, and we're not using OpenMP in that case. So that's pretty much it for like going through the XML. So let's say that I want to run that model. I'm gonna just do my module load 3. I can inspect what's in my XML with free list. So I see that it's gonna give me MOM6 compile. That's my executable. I've already took care of that. Now I'm gonna do free run X for the XML that I'm gonna use, T for the target, so that's a production run. Platform is gonna be Gaia C4 18. And what else am I missing? Oh, I need the name of the experiment. Okay. And oh, it doesn't work. Why is it not working? Because I already ran it. And so I already have a script somewhere. So I say, oh, okay. I don't care about that previous version that I ran. So let me just overwrite it. And now it's gonna do, it's gonna regenerate a brand new script for me. So that's that script over there. It lives in your /dev. So now it hasn't done anything yet. I still need to submit it. So I'm gonna do that. I'm gonna do run the S batch. And now if I do, okay, so that's, I have an alias here. So if I do SQ minus U, that's me. Okay. Now you can see I get my Philips 2-layer example that is in queue. Probably because I've got 287 nodes used by the climate model, maybe. I don't know why my priority is like is going so low now. Anybody get to that point where they were able to just run the 3? Okay, good. Oh, you know what I'm thinking? Well, no, it's only for 1 hour, but for example, okay, so they're gonna be doing some maintenance on Gaia tomorrow. So probably if you had asked for like 16 hours or something, you would not get in because they start flushing or they start like, yeah, flushing the nodes. So they're not letting any new jobs go on the machine. So, so in that case, okay, well, all right. So this one is it's not going to be running yet, and that's a good question. I think I might, well, no, because that's the thing. The batch script is setting up like all your work directories and things like that. So, I mean, obviously I could do it manually and run. I mean, Philips is a small enough model that you can basically run it from the MOM6 example. We could do that interactively, but that's not free. Oh, you know what? Maybe we can try something. We can try something else. Yeah. Yeah. So there's different queues. Yeah, we can try. Let's see if we can try like a queue. There's a queue debug. There should be a queue interactive as well. So maybe we could try. Maybe we can try that. See if that works better. Except it doesn't. Oh. Well, never mind. Mine get in. So, yeah. So this should be actually pretty quick. There you go. Fully didn't crash. Okay, so if I go now to my Scratch directory, I'm gonna go again to that FMS something. And I should get my Philips 2-layer example. That's my output. Archive, story. And this is from today. Yeah, there you go, that works. So that's how, that's where you would find your output. Now the whole thing that I skipped there is the whole post-processing. So obviously, if my XML was full with all the post-processing, that would start transferring that to GFDL and then running all sorts of like post-processing analysis on it, which in this case didn't make any sense. So I just skipped that part. But that's pretty much how the thing function. Now I just ran out of time. I mean, I can stay as long as you guys want to stay, but there's a lot of exercises that we can go through. But if you guys had enough for today and you're like your brain is melting, you guys are allowed to leave at this point. So again, this time around, I tried to be a little bit like slower. There's like a lot of material. There are some exercises in that README. If you want to give it a try, it's not that hard. And there's another branch where all the solutions are. So again, I think I gave you like basically the basics to understand the XML. Try the exercises at home, and if you're stuck, look up at the solution branch. And again, that's something that I would be happy to run a follow-up session on that.
Okay, thanks, Raph. So